Hey, I'm just going to give a quick tour of some of the source code for Asteria and how to mod it and so forth and customize it. So we have the HD Asteria assembly here that compiles out to DLL, and this DLL gets compiled and loaded from the game. Let's see here in the contents. This is here is the source code to this hd.asteria.dll that actually contains all the game logic itself, and is loaded at runtime. So you can create a new DLL just like this in the plugins, and put it in the plugins folder here, and it will be loaded up and used and added to the game as well. So I'll do a demo of that in another video. But I just wanted to give a quick overview of how this plugin system works, so you can have an idea how to get started here. So in this assembly, there is a, let's see, here's a global.cs class, and it just has this this static class called global that can't be in a namespace, and it has a static method called register that will get called when the assembly is loaded, so that we can register everything inside of it. So this here is registering projectiles, items, and enemies, and then there's also a whole bunch of commands that are kind of scanned in the DLL as well, so you don't actually have to register those. It'll automatically scan for any class that descends from command, and so anything that descends from command will automatically be created as a command. It's pretty simple, straightforward stuff here. You just have a description. It actually extracts this part of the class name for the actual command name, and then this method here gets called when it's executed. So there's all kinds of commands in here, like this will just return the current game time as a string. So this execute will always return a string. Like here's to get the current player's location and all the metadata. Oops. All the metadata for this can get, well, not metadata, but you know, the .NET IntelliSense works great on this, so everything should be fairly self-documenting, you know, knock on wood, and should be pretty easy to use to tap into the actual game logic really easily. So there's a whole bunch of admin commands, so I'll kind of give a tour of those. I'll also make maybe a video on how to make a custom command and all that good stuff. So so we have 3 different calls here, calling other static methods that to register the projectile types, the item types, and the enemy types. So let's go ahead and take a look at registering the projectiles. So I have a rainbow. Here's the blaster, the main weapon of the game, and the projectile for that. So each of it has to have an ID, and even though this is an enumeration, you can actually put any integer here, any number, to replace it. Then there's kind of how much damage the actual bullet does, how long it survives, its speed, and then some the particle bits, and then sound effects and knockback, which is not really being used right now. So you can kind of scan through here and see how all these things work. Like here's the flamethrower right here. It actually has an on projectile move kind of lambda expression here. It's kind of very JavaScripty in my approach to adding things to the game, so it's pretty cool. It's nice that C# is able to do this for us. So every time this thing moves, it'll actually render a fire brush on the map in the terrain engine. So the fire for the flamethrower is actually part of the terrain, and so that's pretty cool. And then it also renders when it hits or whatnot. So you just kind of override this to actually implement some game logic for every time the projectile moves. Then let's see here. Like here's various brushes for all kinds of stuff. So here's the ice gun as well. It does a similar thing. Here's actually how you dig. So this is actually rendering fire, and I guess this here is the dig strength. So this this fourth parameter right here is what strength of materials it will dig through as if you use a mining tool. All that good stuff. So that's kind of projectiles. Then let's see here. Let's go to items. Let's go to, so here's our mining tools right here. So here's our tier 1 mining tool. This is some of the first items I implemented, so it's a little older, but basically there's this on-use method that will just fire out a projectile from the player. You trigger a sound and all that good stuff. So then there's a recipe. It's pretty easy to implement. I can't scroll over for that here. You can see what items are needed for the recipes and what location it is. So it's just data here. Not really well formatted, but let's see what else you got here. So here's a dematerializer. So this one's pretty complicated. On start using and on use, as you know, it's actually checking the keyboard state of the player, if the shift is held down and so forth. So that's the mining tools. Let's go to some of the equipment here. Here's the Kingdoms of the Kingdom. So on equip, so all the equipment has this on equip method that is just run to actually edit the player. So this will be a player and the actual item value. So the player class has various fields like max health and things like that. So here's just changing the max health for a suit and so forth. You set the recipe. It's pretty straightforward stuff. So feel free to use and abuse all this good stuff here to make any customizations you want to the game. And so that's all the equipment. And then here's usables. This is pretty cool. So let's see, there's an isn't used immediately flag here, which means as soon as the player gets this, it's immediately used, so it never winds up in the inventory. And we have an is consumed flag, and it will go straight to the power. But this just simply heals the player for 5% of their health. There's an opposite of it that damages the player for 5%. Here's a 1-up for extra lives that we recently added for the Dungeon Live system. Here's a cool way you can see we're adding the combat text. Those are the pop-ups that pop up above the player and so forth. Here's how you send a message to the client. If there's an error, you can play the error sound and send a message instead of actually doing it and so forth. So there's a can use method. Let's see here. Returns a boolean, obviously. Riff creator. This is actually adding a item to the world, so it's dropping a placeable. So if you wanted to drop a chest or whatever, this is actually creating a temporary rift, which is a placeable that we'll get to in the enemies, I think. Actually, that's an item, so it's an item type. Let's go look at placeables here. So here's all the placeables. So here's a light orb, the basic light orb, our proverbial torch. And it is floating here, so it's floating true. It has a sprite animation. There's a variety of different animation types that I've hard-coded in for the placeable. I have a much better animation system for the enemies now, but this is an older, kind of more basic version. There's an animation delay, so this is 100 milliseconds between the frames. So these 18 frames, it'll take 1.8 seconds to cycle through them all. And you set the category to placeable for it to be able to be placed in the world. Then the most important thing for the lights are obviously the light amounts, and then the tier and everything else in the recipe. So for blue, we just cast a blue light, green right here, and the red light's right there. So there's some hidden lights that are used for world editing, so they never actually show to the player. And to do that, here we say draw enable equals false, and then it will never be visible to the player. And the same with the tooltip. We don't want it to pop up a tooltip for them. Obviously, is dematerializable, so they can't dematerialize it. Here's the cool material source. So placeables actually get a long think. There's probably a think as well. There's this on place that gets set. So the placeable actually has a value field, which if you've done any map editing, you'll be familiar with. So on long think, gets called 4 times a second, and it just renders out and sets material, if not loose or solid, at the position of the actual placeable. So placeable position X. This map block width, these positions are pixel positions, and to convert it into an actual block position, you need to divide it by the block width and height constants, and so you got to do that in order to actually write it out. Let's see here, and then on switch, so these things can be turned on and off. Let's see here. This is a triggered material source. So here, material sinks, very similar to the material source. So these are used for creating waterfalls and stuff. It's pretty cool. The door, this is kind of complicated here. Let's see. But it's got a recipe. It's activatable, so it kind of opens and closes, and if it's already closed, it'll play one sound versus another. It sends a broadcast out a message. All the good stuff there. So this kind of has its own draw system. So I just overwrite the on draw to do my own drawing here, and then on draw top, because we always want it on top of the player and all the other entities. We overwrite on draw top, and so I kind of have my own animation hook here, but this is just the XNA sprite batch, which can draw any this kind of direct access to the method that all the graphics are drawn through. So we have a texture here. We just have the one texture. So by default, the game will load a item from the items folder here, and these are just plain PNGs that are scanned on load. So here's door.png. So this is the door graphics. So we have 9 frames, and so there's animations here, and we have these 9 frames. It's numbered 0 through 8, 0, 1, 2, 3, 4, 5, 6, 7, 8. And so to render out each frame, we calculate a frame number. So there's this animation system here that triggers it, but we actually have to figure out what frame dynamically, and there's other systems and other classes that are similar to this, but basically getting the frame ID, we then call getFrame, which will return the frame number here. And so we have so anyways, you kind of get how that works for the animation system is here. So it actually animates the opening and closing while those animations are playing. And so to start an animation, you just call this set animation. Now, set animation has to be called in the actual game logic, but the animation is actually drawn on the draw call and not the update. So it'll actually, on a network game, it will send this information down the wire so that the clients will play the animations. So on draw never gets called on the server, and so that's kind of how that works. Let's see. This Boolean here says to reset the timer, force animation start, and then this is a timeout for the animation. So after 450 milliseconds, this animation will end. So on the draw top, let's see here. There's a placeable animation age that's used that starts at 0 and counts up from the time that the animation starts. So you can use that to calculate which frame to draw. We can use, let's see here, there's a locked door that's similar to door, just can't be opened by the player. Let's see here, here's a chest. So this has an inventory. Let's see here. So I initialize inventory on the on place. So that'll actually create the inventory and allow it to be openable. And then when it's activated, we set the player's active placeable to it and trigger sound and so forth. Let's see here. Now here's the world hypercube, and what this does is it gives a player a copy of everything, but it uses our flagging system so that it's marked as read already, or it's marked as opened if it's flagged and so forth, and you can use reset flags to clear those. Anyways, here's the furnace. So on use, we actually set the active placeable. This is just the basic crafting table here. Let's see here. Can use, no. Recipe on use. Basically just on activate. Just setting that active placeable variable to the actual placeable opens up the crafting window on the client already. So we have all these different crafting stations. Here's the sign, again, active placeable. Waypoint. So let's see here. This sets the starting position. That's all it needs to do to actually set the respawn point of the player. So this is used for that. Let's see here. Here's a rift to set that teleports you, essentially. Here's a portal. So again, this uses the placeable name to, well, let's see here. Placeable value to set the destination. So it will load the map from the world and then send the player there right here or here. So it's actually scanning a linked portal, and if it's found, it will send you to that portal's position. Otherwise, it'll just send you to the default spawn point of the target map. Then it also has its own custom draw here. And let's see if I can scan over here. It's not going to scan for me very well. But and as part of this sprite batch draw, I'm actually rotating the background of the portal, so it gives it that cool Babylon 5 effect, I guess, or not Babylon 5, but the other one. Anyways, dynamite, map.explode, good fun, good times. Nuclear bomb, bigger, much bigger. Be careful. Let's see, switches, time switch, point of interest is just a dummy placeable for AI work and so forth. So that kind of gives you an idea of the items. Let's look at the enemies real quick. How am I doing on time here? 17 minutes. All right. So here we have a crawler. So this is a basic crawler. And so enemy base.add new instance of enemy type. This ID, again, you can put any number there. Just kind of don't stop on anybody else's number. We give it a name. This is used for loading the sounds, loading the texture, all that good stuff. So this has the animation system for the enemies is much more sane than the placeables and so forth. So you set a sprite width and the frames per row, and then you can load any number of frames out of it automatically. So I pull up and again, these guys are just in the content folder. Here's crawler. So this is just 10 simple frames of a walking animation. And you notice now on the enemies, all of them need to face right, and that's just the way we do it. So you flip it left or whatnot. So when they're facing left or whatnot, but they default to facing right. So max health is set to 11. Now this scales with tier, so each tier kind of essentially doubles all the numbers for everything. So max health of 11 is essentially 11% of the player's health at the same tier. That's the best way to think about it. And same with collision damage. This damage will do 11% of the player's health if they're at the same tier as the enemy. So if you're tier 9 and you run into a tier 9 crawler, it's going to take 11% of your damage. Knockback, it's not working very well right now. So is auto spawn means that these guys will automatically spawn. There's some other variables there as well. For instance, here's a bulletproof crawler, and it has a minimum spawn tier. There's also a max spawn tier. Spawn rate limit in milliseconds, so it'll spawn a max of one of these every 3 minutes, and so forth. So is auto spawn avoids cliffs. It won't walk off a cliff. That's set. Blood color, you just give it a color for it to render the blood. On spawn, so here we actually get the enemy object and not just an enemy type object. So the enemy object has plenty of properties as well here that you can check out. So is facing left means, which way is it walking. Now I have my own random number generator cache, super efficient random number system here. So there's flip, and then there's a whole bunch of rolls. So you can do roll, 16 to give it a 1 in 16 chance. But flip is just a 50-50 chance, so it'll randomly give it a direction. Set animation to none gives it a random animation start time to kind of not desynchronize them. Let's see here, and it spawns a particle effect when it spawns there. I don't know why it should never spawn on screen. So, anyways, let's see here. So on long think is your big kind of AI. So this is called 4 times a second, and basically if it's blocked means it's run into a wall. So we just flip the direction and it'll walk the other direction. If it's immobilized, I'm not sure what that's doing. Another programmer just recently added that, but that's if it's frozen. Tell me he did not add that. Okay, all right. Get frame is the animation system. So this takes your animation and the age of the animation, and you just return which frame. And so this is integrated with the main draw system. So it's basically this formula here will just cycle through each of the frames at 50 milliseconds each. Otherwise, if it's any other animation, it'll just return 0, so it's standing still. And then on die, here's actually how we do our drops. So 50-50 chance it'll return an ectoplasm, otherwise it'll return an energy. 25% chance it'll generate some random loot from this method here. Otherwise it'll generate and a 25% chance of generating any other thing. Here's a bulletproof crawler. Notice it has a different ID. A lot of this is very similar to the other one. Let's see, it has a defense. This thing's bulletproof. This is a straight damage reduction on the crawler of incoming damage, so this thing's essentially invincible. Here's the Drake. Has is flying set to true. Now on this guy here, there's a whole bunch of methods on enemy to set the direction. So there's an enemy dot direction variable that sets the movement direction of the enemy, and that's used a lot when you're flying or swimming. Enemy set random angle, so this kind of guy wanders around. So there's an enemy dot target system that is the closest player essentially. And if he's nearby, if he's within 800 pixels, the enemy, this Drake, will come flying straight at him. And so here's all our enemies. You're welcome to peruse through them. I'll do a demo video of how to create an enemy and so forth. But it gets all the way up to some of the bosses here. Very complicated code. Here's one of the bosses, and there's quite a bit of different options and things that you can get working inside of it. So I already talked about the commands, so that's it. So I'll make more videos to help you guys through this, and I'm real excited to see what you make. All right, thanks, bye.